Good morning, children. Welcome to your chemistry online class. So last class we discussed physical properties of haloalkanes and haloarenes. There we learned so many properties. So in this lesson we are going to deal about the chemical properties of haloalkanes and haloarenes. So there are different types of chemical properties, in that the nucleophilic substitution reaction. Okay, let's see. So, chemical properties of haloalkanes and haloarenes. So, there are three types of chemical reaction this haloalkanes and haloarenes will undergo. The first one is nucleophilic substitution reaction. Second one is elimination reaction. Third one is reaction with metals. So, let's check what is nucleophilic substitution reaction. So, what do you mean by a nucleophile? Nucleophile. Nucleo means nucleus or phile means loving. Nucleo means nucleus, phile means loving. So nucleus loving. So what will be that? What is the charge of the nucleus? We know that charge of the nucleus is positive because nucleus containing protons, isn't it? So if we know that oppositely charged will attract. So if a atom or an ion want to has love towards a positive charge, then what will be the charge of the atom or ion? That will be negative, because always opposite charge will attract, isn't it? So a nucleophile is a substance which having the love towards positive charge, so it will carry negative charge. The nucleophiles are the substance which donate or which combine with other molecules or other compounds by sharing of electrons. Those substances will contain maybe lone pair of electrons or negative charge. Here you can see some nucleophiles. There is ammonia. Ammonia is containing ammonium acid. It's contain a lone pair of electron, and that there is OH minus. And here you can see neutral nucleophiles and charged nucleophiles. Every substance which contain negative charge, they will come under nucleophiles. Okay, so we'll detailedly study the types SN1 and SN2. What do you mean by this SN1 and SN2? Let's check. So what is this SN2? SN2. Here the S means substitution, N means nucleophilic, 2 means biomolecular. 2 bi, so biomolecular. So we can call it as biomolecular nucleophilic substitution reaction. Okay, let's see what is this reaction by one. What is the substitution? Substitution means, here you can see in football there are substitute players. If one player will leave, then substitute player will place, isn't it? Similarly, here a substitution occurs. Here you can see this is the reactants, isn't it? If there are two reactants, what will happen? If it is more nucleophile or more negatively charged, for example, in the haloalkane, the alkane, see the halogen group is there, isn't it? So we know that carbon chlorine bond is a polar bond, so there is polarity. So if we know that nucleophiles having the negative charge, so what will happen if a negative charge attracts or attack on that carbon having partial positive charge, then what will happen? The valency of carbon will change, so there should be the leaving of this halogen, isn't it? Here you can see AB plus C gives AC, so it is acting as a substitute player. If this substitute player attack here, this main player will leave. So we'll get AC plus B. Here you can see the SN2 reaction mechanism. This nucleophile is attacking the haloalkane. Here haloalkane, instead of alkane, it's giving L. So here you can see it is a haloalkane. So nucleophile is attacking from the back side and we are getting a transition state. But this all step is occurring in a minute. It is very fast reaction. So there is a bond formation. Here nucleophile, we know that nucleophile having lone pair of electrons or negative charge, that is also electrons. So what will happen? It is, here you can see, it is donating its electron to the substrate. So this partially charged carbon. So what will happen? This bond, here you can see there is a bond between carbon and halogen. This bond will break and this halogen leaves. Here you can see that. So what we will get as product? Nucleophile carbon bond and we'll get our halogen. So it is a backside attack. Why nucleophile is attacking from the backside? Why it cannot attack from the front side in SO2 reaction? So it is a stereochemical reaction or regioselective reaction. Because this nucleophile always attacks from the back side in SN2, because we know that here halogen is there. Halogen also having negative charge. So if this nucleophile attacking from this side, it is also having negative charge and this halogen also having the negative charge. So what will happen? Same charge will repel. So this our halogen group repel, the electrons of halogen group repel the nucleophile. So it cannot attack from the front side. So it will always attack from the back side to avoid the repulsion. Okay. So what will happen if this nucleophile attack here? There will some change occur that we can see. So we studied what is substitution reaction. It is substituting, one group is substituted and one group leaves. Okay. So one group is substituted instead of other group. And we'll check what is nucleophilic. Nucleophilic, we already studied what are nucleophiles. So the nucleophile is giving electrons. So the bond formed between carbon and nucleophile. So it is donating. Because of this nucleophile, the reaction happening. Because of that, it is known as nucleophilic reaction. Here you can see that the nucleophile attacking here, the leaving group leaves and we are getting new product. So what do you mean by this biomolecular? So I hope all of you know the rate of the reaction, that rate equation and all, and you have studied this in your lower classes. Rate of the reaction, what will be the speed of the reaction? How a reaction occurring? So what will be the speed? What are the features depending on the depends for the rate? For example, concentration of reactants. If the concentration of reactants more, the rate of the reaction will be more. There are several. Then what are the concentration, the time, and number of molecules, and the catalyst. These are many factors. I hope all of you studied this. And if a reaction for here, it is known as biomolecular. Why it is known as biomolecular? Means because here the SN2 reaction happening in one step. Only one step is there. So it is a fast step and it is a one-step reaction. And that we know that in SN2 reaction, it is one-step reaction, and it is depending on the reaction rate, speed of the reaction depending only on the concentration of the two of its reactants. So what are the two of the reactants? One is nucleophile and one is the substrate. Okay. So the reaction depending on the nucleophile and the substrate. So it is biomolecular. Two compounds are there. It's a nucleophile and substrate. So two are there. That's why it is known as biomolecular. Okay. So what we studied, and after this reaction there is inversion occurs. Inversion. Here you can see there is a charge. If this nucleophile is attacking, this leaving group is leaves, there is a charge formation in the carbocation. The carbocation, like partially carbocation. So what will happen in order to stabilize this compound? So there is a charge formation, isn't it? So in order for the stability, it will rearrange by itself. You can see from this compound is inverted. So that is inversion occurs in SN2 reaction. So these are SN2 reaction. So what will be by SN1 reaction? Can anybody name what is SN1? So SN1, it is unimolecular nucleophilic substitution reaction. So as same we said substitution, here also nucleophile is attacking, nucleophile substitute to the halogen group. But what is the difference between SN1 and SN2? That we'll check. It is a two-step reaction. There we studied SN2 is only one step, nucleophile attack, that halogen group leaves. But it is two-step reaction. The first step is the leaving group leaves. That is our halogen will leaves. Then a substrate and carbocation forms. The first step. It is the first step and there is an intermediate, that is the carbocation. And the second step, nucleophile attacks the carbocation and forming the new product. Here you can see that the first step, this our leaving group is leaves, that is our halogen is leaving, and there is a carbocation formed. What do you mean by carbocation? Carbon having positive charge. We know that cations having the positive charge. If a carbon carrying positive charge, it is known as carbocation. So what will happen? So it is the intermediate. So it is a first step is slow step. So it is the rate determining step. So the either nucleophile can attack from this side, otherwise either from this side. In SN2 it will attack from only back side. But here the nucleophile can attack from both sides, from front also, from back also. Why? Because there is no leaving group. Leaving group already left. So from either side it can attack. So the reaction will, what will be the product? If it is attacking from the back side, here nucleophile attach. If it is from the front side, here the nucleophile attach. This is the equation. So why it is known as unimolecular? It is a unimolecular means only one reactant. So I can explain that. Here you can see the first step is the slow step, isn't it? Slow step, the carbocation formation step. So the leaving group leaves and substrate carbon now only has 3 carbon, are most stable when there are more atoms distribute the carbocation stability. For example, if there are 3 methyl group, that is if it is a tertiary carbon compound, then it will be more stable. That is the more stable carbocation. If that is secondary, it is least. Then primary, that is very least. That is intermediate transition state, that you can that you have already studied all this, isn't it, in resonance and all. And here this first step is very slow step, and if a slow step if there are 2 steps in a reaction, the slow step is the rate determining step. So what we'll get? So in the slow step there is only one intermediate. So what will happen is this, only one reactant is there. So in order to understand the rate of the reaction, It depends only on the concentration of this reactant or substrate. So that is why it is known as unimolecular reaction. I hope all of you understood what is SN1 reaction and SN2 reaction. Okay. Thank you.